Hello, welcome to the Sunday Science Q&A. We've probably had the largest number of questions that we've had for some months because we are doing coding today. And we have a great panel. We have Eugénie von Tunzelmann, we have Matt Parker, we have Helen Czerski as usual. We have Trent Burton as our producer. You may occasionally hear from him. If you have questions you would like to ask, as I said, we've already had a load of questions in, but as this is live, if you can send it, you can either tweet us at Cosmic Shambles, or you can just pop it in the live chat as well, and Trent will make sure that I know what the questions are that are coming up. A few things just to tell you before we get started. One is if you can support us via our Patreon, that's going to make a huge difference. As some of you know, and I know some of you do support us via our Patreon, it's not been a great year for those of us who rely on live performance and live shows. And a lot of what I think we've cancelled 150 shows that we were going to be doing via Cosmic Shambles. And before, we've always managed to keep Cosmic Shambles going just basically by the fact that we've had loads of other jobs, whereas now we're making an enormous amount of stuff and it's all going here, and we need to try and get 5% of our audience to support us via Patreon. That's all we need. If just 5% of the people who watch our stuff are able to support us, that is great. And there's loads of things I'll just quickly tell you about that are coming up. Uncanny Hour, we're still making that documentary series. So the latest one went out midnight last night, or midnight this morning, which I never quite know how that one. Let's say 1 minute past midnight this morning. That's a much easier way of doing it. Then it was up slightly late, and that makes it more definite. But that one is about why we believe in UFOs and what they mean. And we had a great panel for that, including Sarah Scholes and Dallas Campbell and Mark Pilkington. And we've got a new one coming up very soon, which is about the John Carpenter Apocalypse trilogy with Stuart Lee and Alan Moore and Reece Shearsmith and Samira Ahmed. And so that's going to be up very, very soon. Also got a new series called Tips for Existence, where I talk to scientists and artists about finding meaning and purpose in what appears to be a meaningless and purposeless universe. And guests on that are going to include Neil Gaiman and Tim Minchin and Nicole Stott and Andrian and Francesca Stavrokopoulou and Anil Seth. We've got, did I mention Tim Minchin? If I didn't, anyway, I'll mention him twice. Why not? And he needs that. He's in Perth at the moment, and the scenario there has suddenly very rapidly changed just before he was about to do a live gig in front of 5,000 people. So, and all of that stuff is accessible if you have Patreon, as well as fortnightly shows called Reality Talks, where I do a kind of 50-minute talk about different perceptions of reality, and then joined by someone. The next person going to be joined with is John Higgs, who's written a fantastic book about William Blake, great book on Timothy Leary, and also Stranger Than We Can Imagine and Why the KLF Burnt £1 million. So there's loads of extra stuff, plus weekly book shambles, and this every single week. So if you are still doing okay and you have some spare money, this is the best place to send it. Go and check patreon.com/Cosmic Shambles. Also, Wednesday night at 8 p.m, there is a virtual book launch for Dean Burnett's new book, Psychological. So
that made him sound like some kind of pyromaniac.
Dean Burnett.
I've never seen him in that light before. Yeah, burn everything, right?
Yeah, that's how so many Chumbawamba songs start. Give the anarchist a cigarette. So yeah, Dean, we're doing that, and we're doing next week is going to be a show with, amongst others, Dr. Mark Richards. This is the next Sunday show, and we're going to be talking about weather and atmosphere. Helen Czerski, hello.
Hello.
I'm going to get straight into it. Your This Week in Science, people love it, and it's such an interesting thing. And your last week's one had a lot of people asking more questions, a lot of people going out to find out more about this book. Tell me, what happened in science history this week?
Well, since you just trailed that next week's is going to be about the atmosphere, I'm slightly regretting. Oh, my thing's just switched. I've got a picture to show you. It's just switched itself off. I'm slightly regretting not leaving this till next week. But the problem is, it happened in science this week, so I have to do it this week. And it happened in 1930. Here we go. And it was the invention of something called the radio sonde. Now, this is going to sound very boring, but I'm going to show you a picture because I'm so high tech that I couldn't be bothered to do the thing on my screen. So what you can see here is a guy holding up a balloon on the back deck of a ship, and attached to the bottom of that balloon is a little package, and that little package is a radio sonde. And what that balloon is about to do, so this was from a couple of years ago at the North Pole, and what that balloon is about to do is to rise up into the atmosphere. They can go sort of 20 or 30 kilometers up, and they measure all the way up. They measure temperature and pressure and humidity and all these kind of things, and eventually they pop. So basically the balloon can expand to, I think, 10 times the diameter of what you just saw, because obviously the atmosphere gets very thin, the balloon just gets bigger and bigger and bigger, and eventually it goes pop. And the reason that the first radio sonde in the modern way of using it was flown on January the 29th, 1930, And it was sort of all happening at that time in the 30s. You know, radio was coming along. People were thinking about weather forecasts. They didn't have very much information about the atmosphere. And these balloons that could go all the way up, could carry that little package all the way up, you know, 10, 20, 30 kilometers, could see the atmosphere for the first time. So they discovered the tropopause, which is where the layer of the atmosphere where the weather is, where the top boundary of that is, and the stratosphere begins, and the next one up. And so the reason that the radiosonde was such a big deal is that they are still released today. So there are about 1,400 every day. And the great thing about it is that there are airports, there are sites all over the world, and they all release their balloons at 0 and at 12 UTC. So at the same time, like that's at 3 a.m. in some random place, and some person has to walk out into the middle of an airfield and let this balloon go. So across the world, twice a day, all these balloons go up at the same time. So we basically get a global snapshot of weather all over the world. They are mostly constrained to land. There's a bit of a problem that we don't have many over the oceans, although we do release them when we're at sea. So yeah, so it's 90 years ago, and it's kind of a modern thing and an old thing at the same time. And satellites can't do this job because they can't get the horizontal resolution. Basically, the atmosphere is in layers, and you really need to be able to see the difference between those layers. Looking down through a satellite doesn't tell you exactly what's going on. And so I just love the idea that this first radiosonde was released 90 years ago this weekend, and then they send their signals back via radio. So now they first used to send them via Morse code, and then later on so someone had to decode the Morse code, and now they send them back via radio. So yeah, but I love this idea of them all going at the same time, twice a day, to take a snapshot of the atmosphere. So that is today in science.
That's wonderful, and I am always looking for any Jungian synchronicity now that we're all in this kind of isolation, so I clutch at any straws. And I'm glad to say that just before we started the show, I was talking with one of our other guests, Eugénie, about Nicholas Roeg and his brilliant film Don't Look Now. And another of his films that I've watched in the last few weeks is Walkabout, which has a lengthy scene involving the sending up of weather balloons to observe the atmosphere. So there we go. That's the best I can do. Your Nick Roeg link there of art and culture, the two cultures smashing together. Matt Parker, we were having a lovely time in Toronto. So, but we're not now.
Yeah,
you're in the same place that I've been for. That you've been for a year, and I've been for a year. What have you got for your show and tell today?
Right. So, for my show and tell, it's actually something I acquired on the same trip when we were over in the States. Well, we did a show in Canada. And that was like the beginning of my year of travel. And I had no idea that was like also the end of my year of travel. But along my journey, I picked up this is 1 bit. It's a bit of a computer, but it's also a single bit. This comes from an IBM computer from 1948. And so this was the first, first calculator. This is back when calculators and computers were synonymous. They were the same thing. In fact, the IBM 600
one of my favorite things is whenever we talk about the improvement in technology, very often that is the moment that you will freeze. So we got up here. So IBM calculators, computers, roughly start from roughly around there.
Oh, yeah. So just saying, when it came out, it had the new feature of being able to do division, which everyone got very excited about. And it was all done using these vacuum tubes. So each one of these is a single 0 or a 1, if you were to put it in a modern sense. And so I love the fact that this is one individual bit. Actually, I got this of a friend of mine, and they've got a rack of 8 of them. So they've got a whole byte that they keep on their shelf in their office. And when I expressed how amazed I was at their byte, they're like, oh, I got some spare bits somewhere. And so they grabbed me out one of these. And for the purposes of this show and tell, I went and weighed this to see how things have improved over the years. And this is 40.6 grams for 1 bit. This came from a computer before you really had storage. This was punch card era. So this is more analogous to the processor or the RAM, depending on how you want to look at it now. I've decided to call it the RAM. And a modern iPhone has about 6 gig of RAM. So I worked out if you wanted to have a modern smartphone with these, if we hadn't developed this technology, it would take 2,000 2 million tons of these to do a single modern smartphone. So that's roughly the mass of 1 million Teslas just for the RAM in a single phone, which is just spectacular. So if we hadn't advanced technology on from this, there's no way we would have the modern computing and programming we have today. But this is where commercial storage started, a single bit.
And when the thing that came in, how many of them did it have?
Great question. I'll have to check. It'll be on the order of tens to 100. So this was like one of those classic kind of washing machine sized devices. So this wasn't yet like they weren't at the level of like the full room where you've got all the spinning drives and everything else. This was like one single washing machine, and it would do one punch card at a time. You put a punch card in, it would read the data, do a calculation based on that, and then put it back onto the same punch card. And that was your whole process.
Just think, though, if those phones were all 2 million tons now, how much slower conspiracy theories would travel. So, with us give, there's take. Also, I should say, when Matt and I and also Lucy Green, when we were in Toronto last year, because we all love technology, we saw one of the greatest pieces of technology ever, which was we were in a shop called the Monkey's Paw. If you know Toronto, you will know Toronto has fantastic secondhand bookshops, and the Monkey's Paw has really intriguing idiosyncratic selection. And was it called the Booker Mat? I'm trying to remember.
It was the Booker-Mat, or the book. Wasn't the Booker-Matic? I think it was the Booker-Mat.
Yeah, and you would get a token, I think, for about $3, and you would put it into the machine, and it would go bang, and a book would be delivered to you. And they actually added a ping sound because they found that the ping was the thing that made it authentic. If a book was merely delivered and just crashed it, but the fact that it pinged on point of delivery was the bit that made it perfect. So if you are in Toronto now, you probably know about it anyway. And if you ever travel to Toronto, Monkey's Paw is one of the many great bookshops there.
If anyone's struggling to visualize the size of the Booker-Mat, it's roughly the size of an IBM 604. Just for reference.
That helps. And amazing. I mean, the Booker-Mat back in 1948, imagine the size it would have had to have been to deliver a book with a ping. Ping sounds have really managed. The nanotechnology of the ping has been greatly improved. And I think actually somewhere, Trent, we'll put it up. We'll put it up on Cosmic Shambles because I think we've got a little film from a while back of us using that machine. So you can see that. Eugénie, thank you so much for joining us. Now, let's get. The reason I'm going to get straight into this is just because we've got so many questions. What is your show and tell for us today?
My show and tell it's actually just a bit of playing around. It's something that I've been doing in lockdown because I suppose, like everyone else, lockdown's a bit repetitive. So I started playing with. I was thinking about video games and writing video games, but I'm particularly interested in video games that have sort of interesting or unusual inputs or outputs. So not just always a controller and a screen. And I was really interested in, I was very inspired by the work of a guy called Robin Baumgarten, I hope I'm saying that right, who has done various sort of interesting things with LED strips and sort of unusual controllers. So I've just started playing with a Raspberry Pi, and I've got it here. Let's see if I can get it on screen. So what I've been doing is really just very, very early days. It's nothing impressive yet. But I've got one of these, like, can you see this? Like old arcade machine controllers, and I've just got it hooked up so that it makes this little like rainbow line go along the LED strip when I turn it. It's not a game yet. It's just a little bit of a toy, but it's really weirdly satisfying to play with. But nonetheless, it was. I showed this to Matt a couple of months ago, and that actually led to a collaboration between the two of us. Matt, I don't know if you want to talk about it, his Christmas tree lights.
Yeah, I bought a couple of years ago. So the strip that Eugénie's got, you can individually address each of the LEDs, which means you can tell each one the individual color to go. And I'd bought some of these, but more like Christmas tree light style. And I'd always wanted to wire them up to my Christmas tree and do lighting effects, similar to what you just saw there. Except I'd never got around to it. Whenever I gave it a go, it was so complicated. And I was on a call with Eugénie, and I saw she had. Did you show me the kit, or was it on your table? I can't even remember.
I think we were just talking about like, what are you doing to pass the time? And I was like, I'm surrounded with bits of Raspberry Pi and LED strip because this is what I've been doing this week. And you were like,
because I've not have made any progress, and so it's an interesting thing where I find if you often tell someone a project you're thinking of doing, it makes you less likely to do it because you've already got some of the satisfaction of talking about it. And so I was like, yeah, okay, I wouldn't normally. This is a project I really want to do, and I've just not done it. I think it's going to be great, but then I kind of felt obliged because Eugénie sent me a guide, and she posted me a few bits of kit that like stuff that you got to buy 10 of, and so like little adapters and plugs and diodes and stuff. And so with Eugénie's help, I was able to wire up 500 of those LEDs onto my Christmas tree, and then I used my camera in my laptop to watch the tree as I turned the lights on one at a time, and it would record the vertical and horizontal position in each shot of where that light was. And then I'd rotate the tree and do it again, and then rotate and do it again. So then I had the 3D coordinates of every single LED. And the problem is, so you see on Eugénie's strip, the lighting effects always go along the strip because that's just the order that they're wired. They have no idea where you put that wire in 3D space. But now I could do lighting effects up and down the tree in 3D. And Eugénie then, because you, I mean, as a VFX person, you wrote guest code that I then ran on my Christmas tree.
I did, yeah. So I was looking at ways of doing kind of procedural animation in 3D of the lights, and then kind of encoding that into an image format so that it could play back on the tree. And it worked, amazingly. But there we are.
Downplaying the effort it took for her to a whole way of encoding the lights, so we could then put them on the tree, and we had a immense amount of fun.
Yeah.
Have you seen the other video, Eugénie?
I have. The second video is a triumph. Everyone else's guest code.
Accidental. So we spent months on this other project. We put it on the internet, and YouTube's like, that's okay. Here's 400,000 views. And we're like, oh, that's good. I'm very pleased with that. And I just said, if anyone else wants to send code in, I'll try it on the tree. Because I like to encourage people to give it a go, right? I got like about 60 different bits of code, all in Python, to run on the tree. And one night I just sat down and I filmed myself with no edit, nothing, just a camera and me trying 60 bits of untested code on my Christmas tree. It's just gone past 3 million views on YouTube. So YouTube, for some reason, decided an unedited live. I mean, halfway through, I went and got a beer. That was the level of effort I was putting into that video.
What's particularly funny about them is that at least the first, I can't remember what it is, it's like the first 5 or 10 just segfault. Like they don't work at all. It just doesn't run. And the people are like, I'm going to keep watching this.
I know.
Failure is really important. I mean, I've definitely seen that at times when you've done, where there is a point where people lean so much further in. When, one of the nights at Hammersmith, I can't remember what went wrong. And the first time, and then people are gripped. If you show people success, I mean, that's one of the things, I was talking about this with Alam Shahar the other day, which is perhaps lacking sometimes in science education, which just goes straight to the right answer, and then they found out this. That point of saying these failures lead to this, I think is gripping. We've got 40 questions. We've got 40 minutes. We're going to see. I didn't mention, by the way, before, because I'd forgotten, of course, Eugénie hasn't been on this show before. And I should say she's a visual effects artist who has worked on things like Batman Begins and Interstellar, and most importantly for some of the Uncanny Hour listeners as well, The Greasy Strangler. You can check out more of her work by looking at IMDb. Let's get started off with hashtag gifted parents question. Thank you for joining us again. And your kid wants to know, I'm going to throw this to Helen because I think it's a Helen question. What changes in the structure of snow mean that some is good for building stuff and some is just powdery and falls apart?
Right. Well, snow is really complicated. But in a short period of time, the most critical thing is the relative humidity of the air where you are now. Because if everything is very wet and damp and things evaporate and condense very easily, basically the atmosphere gives you extra glue for snowmen. So if you have quite a moist, relatively warm atmosphere, if you put two snowflakes next to each other, they will stick, and actually you'll get more condensation. Water atoms move around and kind of they'll glue themselves together with more water. If you have super dry, if it's very, very cold and it's very, very dry, snow doesn't stick together because it's just, you know, a crystal and another crystal. So basically being quite warm and quite wet makes a big difference. And also I think in the UK, these big fluffy conglomerations, they give you big, good building blocks to start with. But the temperature and the relative humidity, both where the snow formed and where it is now, are the critical parameters. But so you kind of need you need lots of snow. So you need it to have been quite humid, but quite cold before. And then what you need now is warmish, relatively warm, not above zero, but lots of humidity. And then your snow will probably stick together.
And if you look back at last episode also, you'll find out about how we in the UK have never seen that snowflake. We may well have often seen illustrated as well. We may well put up a clip of that at some point. This is from Jonathan P. Eugénie, this is Jonathan B. Sorry, Eugénie, this is, he would like to know, I'm curious how far down the rabbit hole of programming knowledge a visual effects artist needs to be. Can you just know how to use the programs without knowing how to write the actual code that makes it tick? For example, I'm okay using Photoshop, but I have no idea how any of it works.
Okay, so good question. The answer is that we tend to talk about visual effects artist as if it's a job, like, you know, I'm a visual effects artist, but in reality, that there's not one job that's visual effects artist. The visual effects has vast numbers of sort of individual skills within it. So we have match move artists, layout artists, modelers, textures, look dev artists, riggers, animators, lighters, compositors, effects artists who work with sort of physical simulation, character artists, and then you also have, outside of this sort of artist field, you have, you know, producers and managers, you have tech support teams and research and development. And so the answer is it depends which one of these roles you have as to how important it is that you can code. So the research and development artists, for example, the developers are absolutely all coders. And then the people in some of the more technical aspects of art, so in physical simulation or character rigging, will tend to be pretty confident coders or scripters as well. But then you have some people that use the tools and don't need to know any of that at all. So, for example, we have digital map painters who paint backgrounds in things like Photoshop, and they wouldn't be expected to have to do any programming. So the answer is depends what role you're doing, but no visual effects could sort of happen with zero programmers. I hope that answers it.
That's brilliant. Thank you. And Matt, Sue would like to know, well, basically says, explain binary to me, please.
Great. Thanks. A surprisingly common question, and actually, like the one of the great things about the vacuum tube from before, the reason why we have binary is when you've got something that simple, it's basically a fancy switch that can be on or off. And we've found different ways of doing that physically over the years. The vacuum tube uses effectively a heating element so that you get more electrons, and suddenly you can conduct where previously you couldn't. And that's the kind of the on and the off. And we have more and more elaborate ways of doing that. I once built a computer out of dominoes, because a domino is either standing up or fallen over. And so if you've got something which can be in one of two states and you've got a way to kind of pass that information along, you can then have computing. But because it's always either on or off, you've only got one of two options, you have to use binary. And so binary is effectively counting, but you can only use on or off, or 0 or 1. And so instead of normally counting on your fingers, you would count, up to 10, and then you run out of fingers. Binary is like counting on one finger, or just raising your hand instead of fingers. So you count, okay, 1, and you're like, oh, now I'm out of options. And you go, oh, you know what? I'll use my other hand to be 2, and then I can bring this one back down again. And then you're 3, I'm out of hands again. You need someone else. And so it's the same as counting on your fingers, but instead of our base 10 where you've got 10 fingers you can put up and down, you've only got 1. Counting on one finger. There's my short answer for what is binary.
Oh, Robin's gone all muted. Couldn't hear anything he's saying.
We've lost the sound of Robin.
Sorry, it wouldn't allow me to unmute there. The reason is there's also, one of those things where you go, this would be the perfect time for someone nearby to start using a chainsaw. Well, that's exactly what's happened. This is this is from Peter Cubbin. He says, I only have one coding question. Do you use tabs or spaces? Eugénie.
Well, I mean, I don't know that I can commit myself to something with so little thought. I'm going to say tabs.
Great. I love questions like that.
We probably need some context here. I'm feeling a bit bad for the audience.
I don't care, because we've still got 36 questions. Okay, so if something like that happens, we take it. This is an interesting one, Eugénie, again for you, which is I suppose this kind of comes into the idea of the uncanny valley, and in particular in using CGI to create a human look. And Adrian wants to know, why are eyes so hard to do in CGI? There's always something which isn't quite right.
I mean, it comes down to complexity, like eyes, and particularly, I think this area around your mouth. The truth of it is just the complexity of what's going on inside there in terms of musculature and all of that sort of thing. Hugely complicated system, but then to add to it, you have the psychology of facial recognition, because I'm definitely not a brain expert, but as I understand it, there's a whole kind of area of the brain dedicated to recognizing faces that's kind of distinct from recognizing everything else. We're extremely perceptive about face and facial expression. So you've just got something that is an extremely complicated system, and then you're showing it to a part of your brain that's particularly good at spotting things that are wrong with it. So that's ultimately why you end up in the uncanny valley with things that are close to correct, but they feel a bit creepy.
That's it. Because I was thinking, I was doing a show the other day, which should be out soon, about The Thing, and Rob Bottin's effects in The Thing, which are very much more in the the highest tech version of kind of Ray Harryhausen territory. And a lot of people I spoke to said still CGI can't create the same creepiness that you can get from watching something like The Thing. And I wondered how you feel about that.
I don't know. I mean, I don't. In terms of whether to use sort of special effects or visual effects, so the physical or the digital, both have their strengths and the things that they do best, and they're also their own limitations. And I think that there's a place to use everything, and there's how you direct it, and too much of showing the monster and all of that sort of thing. I mean, I think it's entirely possible to create something creepy with CG, but I think you've got to be careful about how much you show of it, where do you use it, all of those sorts of things. And The Thing is a masterpiece, so that's why it works so well.
Yeah, it does have that as well. Being a masterpiece always comes into the.
It's probably worth adding, just digging around the scientific literature these days, there's quite a lot of papers on odd things that scientists have never studied, like how splashes work and fur, that they're only being studied to help out CGI people. Like the basic physics, the scientists have just gone, oh, well, we know about the important bit, and there's all these details of exactly where the drops go. We don't need to know that. We're not really interested. And then there's this new collection of papers who have gone, actually, we do need to know where all the drops go, because otherwise it doesn't look realistic. And so there's this very odd kind of subfield in science now where there's all these physical things that scientists like me who study the natural world have just gone, oh, well, I know what's generated. I don't need to know exactly where it is or exactly how it works. And then the visual effects artists or, programmers coming along going, actually, we do need to know. And so that they are writing the papers on that.
I think. See, that's sorry.
I think that there was, I only sort of skim read the article, but I think there was something just yesterday about how some of the snow simulation that had been done for Frozen has been used for sort of various crime scene analysis and things like that. Since then, I'm not sure the specifics, but the snow simulation in Frozen is amazing. So yeah, touching on exactly that.
I find it fascinating just that it shows us how often we don't know what we're looking at, but we do know when it's not there. And that to me is just part of their fascination. Owen K Matt wants to know, Matt, what plans for calculating pi by hand from home?
Oh, that's a great question. So Traditionally, I calculate pi by hand once a year on Pi Day, which is the 14th of March, because in the US way of writing dates, that's 314. And I'll take any excuse to celebrate pi. And I alternate between two different styles. So some years I calculate it by hand, doing it with working out. So you can get a lot of just pure arithmetic calculations, which will give you pi exactly if you do infinitely many steps. Now, obviously, that takes longer than we have available, but if you do a finite number of those, you'll approach pi. And so I personally recommend 1 minus a half plus a third minus a quarter plus a fifth minus a sixth. And if you alternate adding and subtracting all the unit fractions, and once you get a final answer, multiply that by 4, you get pi. So that's my recommendation if you want to dabble in the pi by hand. If you want to actually do it with a physical experiment, which is what I do on the other in-between years, my favorite is cutting a circle out of cardboard. And if you've got accurate scales, you can weigh it. And if you weigh the original square and then you cut the disc out that separately, the ratio of the two of the masses will be the ratio of the areas, and you can use that to get pi. So that's my other home pi technique, or a pi pendulum, other recommendation.
Again, I think we have got footage somewhere of the pi pendulum, of course, which was done at the Albert Hall, amongst many other places. Though the Albert Hall perhaps was technically, I think, and the most problematic. It's very much a Victorian building that was not necessarily made for pendulum-based pies.
No. And everywhere else, I did a pendulum length, which was a quarter of acceleration due to gravity, which means that it takes pi seconds to do a back and forth, a whole period. Whereas in the Royal Albert Hall, we did the full 9.81 meters, which was, we just made it more complicated than we need to. But it meant that it was pi seconds per half swing.
I don't think you'd have a career if you hadn't made things more complicated than they need to be. I feel that's very much part of your unique brand. This is from Irene or Irene. I apologize. I think it's Irene. And I'll throw this to you, Eugénie. This is, can someone explain engines to me in terms of computer game stroke effect? My son often talks about how he prefers video games that use specific engines, and I'd love to know what on earth he's talking about.
The engine is... it's sort of like the system that allows a game to be written. So when you start writing a video game, you don't generally start from scratch. You start from a pre-existing sort of piece of software, I suppose, which has within it a lot of inbuilt things that you definitely already want, like user interaction and physics and things like that. So there's kind of a base level of programming that already exists that you build on top of. Because they treat, for example, lighting differently, and I suppose input and output of things, then they have their own sort of flavors in terms of having different looks or similar, allowing different functionality. So I suppose it would affect the end game experience. So games that were built on a similar engine might have similarities.
Brilliant. Thank you. I hope that helps, Irene. This is now a question from Dean. This is actually not from Dean. This is from his daughter. And what she asked is, what number is 1 less than infinity? Where do we start with? I'm going to... Helen, I like the look on your face there for this question. So let's start with you.
Oh, I'm laughing because it's such a math question. The reason I'm laughing is that this is
know, but
I feel gets that out of bed for.
You are something of a polymath. Where would you start with this?
The number that's 1 less than infinity. Well, as mathematicians will tell you, there's more than one kind of infinity to start with. So you've got to worry about that. You can have infinities that get there in different ways. I guess they can get there by doubling where they are now. They can get there by adding 1 to where they are now. They can get there, so you've got different types of ways of getting to infinity. I'm watching Matt's face here because I'm going to get picked up on something.
I'm marking you as you go along. So carry on.
So I don't think I'm the physicist. I'm in the practical world where we deal with realistic things. But I would say that 1 less than infinity is just 1 less than infinity. It depends. I'm not sure you can always add 1 and make a new infinity, and then add 2 and take 1 away from that. So I don't know. I think it's a very large number, but it depends on what you want it to do. Now let Matt give the proper answer.
Oh, no, Matt.
Okay. So the problem with infinity is it's not strictly speaking a number. It's a measure of how many numbers you've got. And that gets a bit confusing because it's the same thing at lower numbers. Like if you count to 10, you've got 10 numbers. If you count to 20, you've got 20 numbers. But in theory, there's always another number. And so how do you measure something that goes on forever? And so infinity is a measurement of how many, let's say, whole numbers there are. And Helen, I gave you half marks for your different types of infinities, which was good work. You had a whole mark until you started talking about doubling, and I took 1 off for style. And so that's when you've got different sized infinities, because it's possible to have a different number of things, even if there's infinitely many of them. So, for example, there's one type of infinity, whole numbers, but there's a different infinity of numbers if you include decimals between 0 and 1. And that's a different measure of how many, infinitely many things you have in that category. So sadly, you can't have 1 less than infinity because infinity is not a number. 1 is a number. And so you can't combine them. Although I did have a lot of fun this week. Someone sent me a website that had the fun fact that 170 is the biggest factorial possible, and 171 factorial equals infinity. And what they had done is someone had hit the limit for how big the memory was or the way that they encode binary numbers in their computer, and just gone, well, if it's too big for a computer, it must be infinity. So that's my fun fact for the week.
God,
infinity is actually 171,
time, doesn't it?
Factorial.
Thank heavens for that. Eugénie, this is from RA, who would like to know, when you're doing real world visual effects, is it created in an infinite space like a vector graphic in Illustrator, or do you just do it at 25 frames to save time?
So if we're talking about, do we mean sort of the animation of things in real life? So say the movement of foliage is calculated once per time step generally. So for a film, 24, for other things, TV, 30, can go up. But generally calculated once per time step, sometimes more to get better motion blur. So over the duration of a camera shutter being open, you don't want everything to move in a straight line. So you can, what we call subsample within the time step. So then you would do more than 24 per second. But basically, yes, we calculate things once per time step.
Brilliant. Thank you. This is one for you, Helen. I think this is from Danilo. How can we better educate the public that computer simulation / models, particularly when it comes to things like climate, isn't just guessing?
Yeah, it's an interesting question, because the problem is that in any simplistic debate, there's a big difference between not knowing everything and knowing nothing. And it is always very, very hard to convey what the difference is. So in practice, just to provide some context here, a really complicated model like a climate model is basically a flight simulator for a planet. It takes the knowledge from lots of different scientists over hundreds of years, working in lots of different ways, and it does its best to combine them. I mean, it's kind of the sort of engine that Eugénie was talking about. It's got all these bits of physics in it, and you can run it forwards and backwards. It obviously hasn't got all the physics in it because it's not the same size of a planet. So the problem is that if this thing produces an output, then someone in the public goes, oh, well, do you know that next Wednesday it's definitely going to rain at 3:00? And you go, well, there's a 30% probability, I think, that it's going to rain next Wednesday at 3:00. And that sounds like I don't know whether it's going to rain next Wednesday. So I think a lot of this comes into this discussion about science more generally that we're seeing with COVID, which is talking about uncertainties, and that the game is not knowing the truth. There's no absolute truth here that we're all playing with. It's reducing the uncertainty around what we know. It's narrowing down the walls on either side, if you like. And then, next Tuesday, is it going to rain at 2 o'clock or 3 o'clock? There's a bit of uncertainty in there, but it's going to rain. And the big message is we think it's going to rain. And then there's this kind of wiggle room either side. So I think that the answer to this is actually talking much more generally in life about probabilities and it being okay not to know, and nuance. And it's one of these things that really drives a lot of us mad, because actually the problem is the world's complicated. Human brains are desperate for patterns to make it simpler, just to cope. There's all this stuff I can't cope. There's more stuff, and I just want a pattern so I don't have to deal with all the different types of stuff, right? And I think we have to help people be comfortable with the idea, first of all, that not having a completely perfect answer is okay, but also that this is massive amounts of human knowledge. We can trust it. And the problem is, how do you trust a model? And we have to show something of how they work. And so there's this combination of trust in this enormous edifice of science, and also just it being all right with not knowing exactly. We don't know anything. We think we're in control a lot more than we are. So there's this, we're always dealing with uncertainty. It's just that when it's numbers, we don't like uncertainty because we want it to be 4. But that's not how we know anything else about what's going to happen next Tuesday. So yeah, it's difficult, but I think being confident with nuance and being absolutely transparent about what we're doing, so it inspires, so it earns trust, that's the way to do it.
I think that's very this a lot on here, just that. I mean, we've seen a lot with some of the theories that people have thrown up about COVID, which is to ignore a huge amount of the picture and say, but I've got this one bit of information which it is definitely right, and therefore, and it's fascinating to watch that, whether it's COVID, whether it's over climate change, the way that kind of thing is used, or whether I still think one of the best ways of observing that thinking, which looks for a certainty and entirely ignores a far more complex picture, would be something like those people who, Holocaust denialists. If you look at their method, and it's a very simple method to look at and go, it ignores all of this to get to this answer, which I think it plays part of it as well. And as we always say on this, it's not necessarily saying about getting the right answer, but it's being able to discount a lot of other answers and say this is definitely better than these answers for the time being with the tools that we have.
It's always going to involve trust, because no one has time to understand all of weather models and all of economic models and all of any other model of the world that you might have. No one has time. So there's always going to be trust. And so fundamentally, you need a trusted society that can demonstrate it earns that trust. And then you have a reason for thinking that this model, why should someone listen to you rather than a crazy COVID denier? It's because you've earned trust, because you talk to everyone about what you're thinking all the time and what you do and don't know, and that's that earns trust.
Were you good? Sorry, did you want to add something to that?
No, that's amazing. I think it's the nuances of conveying uncertainty is a whole skill and field of research of its own, and I think it's one of the biggest challenges is conveying how we can embrace and deal with uncertainty in quite specific ways. But it's hard to communicate.
Better, but there are so many tools that are being used by those who wish for certainty, however wrong it is. This is from Josh. Eugénie, this is for you. Did you have to do an intro course in astrophysics before you started working on Interstellar? Did Kip Thorne sit you down and go, right, here we go, here's your next 6 months covered?
Sort of. When we started working on it, I mean, it was a long collaboration. It was sort of a year and a half or something. And I mean, yes, Kip did actually come over to London and sort of sat us down and gave us some lectures on black holes and so on. But mostly, I learned what I learned about it, and so did the rest of the team on the job. Really, he was providing the algebra, as it were, behind. That drove everything, and we were sort of learning about what black holes look like as we went. So I didn't have to do an introductory course, but I did have to learn quite a lot. But then I think everyone on the film did.
Such a great film, such an interesting film. Greg would like to know, I'll throw this out to all of you. Greg says, what is the best coding course or online tool for someone in their 60s to learn how to code? I've got basic computer skills, but I'd like to know where to start on this. So, Matt, do you have any opinion on that?
It depends why you want to program. Because there's so many different things you can achieve. Personally, because I first started getting into programming properly to do mathematical simulations and to solve problems. And so I would recommend picking a language that's got a lot of online resources for it, which Python is almost unavoidably the correct answer there. And then there's something called the Euler Project, which is a series of programming challenges. And they're actually independent of language. So whatever language you want to learn, you can use Euler Project. And they just say things like, calculate the sum of all the square numbers less than 1,000. And you've got to work out a way to program the steps that would, automatically do that for you. And the challenges get gradually harder and harder. And if you can either just try to solve them as they are, or see if you can be efficient in putting your code together. And so that's how I first got into programming. And then since then, I've expanded into, could I now use the same skills to scrape web data or to automate emails and so on. Whereas I think Eugénie would who uses programming for very different things to my math simulations.
Yeah, well, I was very lucky. I learned very, very young, which means that my recommendations on how to learn are going to be based on copy things out of your local computer magazine, which maybe not so relevant anymore. But I mean, I would say that it's slightly, I suppose it's slightly off topic, but Arduino, the programmable microcontrollers that you can get, there's a starter kit for that, which I happen to have, which I just noticed was really good for kind of beginners programming and making it drive hardware as well. So if you're interested in electronics, I found that really good. I just thought it introduced the sort of processes really well.
There's one thing I would add, which just builds on that, which is kind of a different way of version of what Matt said, which is that you need to code for a reason. Like, you don't learn coding. We all learn just by doing, and that means you need to be doing a thing. So invent a thing. Next Christmas, you want to program your Christmas tree to do something completely ridiculous, right? But if you have a specific end project, you will be able to learn how to do it. But if you just try and learn to code, you won't go anywhere. So it always has to be very end goal focused, I think. So invent the most stupid project you can imagine. Matt's got some brilliant ideas, and just work towards that. Work out what the stages are, because if you just want to learn to code, you won't do anything.
Sentient to take over the world. It all started back at the end of January when Helen, just offhand comment. This is a question for you from Andy, Helen. He would like to know, can you make a graphic showing the carbon dioxide absorption by trees versus carbon dioxide emissions, starting from human breath down to the most inefficient way of burning hydrocarbons? A neat scale appropriate graph could go a long way, in my opinion. So what are the problems with that?
The problem is it's complicated. It's not the same. It's not the same for all trees. It's not the same for all trees. It's not the same for all people. It's not the same in all situations. And this is one of those things where nuance really matters. There are order of magnitude calculations that are different. One of the things I've been like, when the BBC used to make more science documentaries than they do now, I would pitch programs about the atmosphere every year, about what's in the atmosphere. And they never went anywhere because they were like, we can't see it. And actually, so I think there's a deeper problem in here, which is that there are a lot of things in the world that our knowledge is held back because we are visual creatures, and because it's a huge amount of work to be able to see it, to work out a way to make it visible, we just don't. So we don't know about them. So we leave them out of our worldview. So the reason the graph doesn't exist is it's not that simple. You could make an order of magnitude thing, but it would be wrong in so many ways that it might not be helpful unless you were super, super careful. But what might help is sort of visualization things, like, how gases diffuse in different environments. I always wanted one that showed nitrate and sulfur compounds coming out the back of car exhausts, for example. And it's really hard to show how that mixes into the environment. So the reason the graph doesn't exist is because it's more complicated than that, but work could be done on this. It's just that no one's got there yet with actually doing it. But you have to be so careful when you're doing this kind of stuff in order not to make the problem worse. Because as soon as you give people a nice graph, they'll go, oh, well, I see this part of the graph and that part of the graph, so I just have to go from here to here. And that's not it. That's not the game. Once you've given someone a pattern, they just see in terms of the pattern, and sometimes that's useful, but it doesn't mean they can use the pattern as a sort of the only truth. So it's really hard. I'm sorry.
No, that's great. Thank you very much for that. This question for you, Eugénie, from Linda. She would like to know, in terms of CGI, how does non-visual CGI work? Say something like wind. Is the wind coded separately, or do you manipulate each object?
Oh, that's a good question. I mean, so to do a wind effect, as you pointed out, can't see it itself. You can only see its effect on other things. So the other things will be simulated, and they will be driven by something that represents the wind. So generally, we would create some kind of vector field, and that would push everything around. And if you're doing your job well, you use that same vector field to drive everything in the scene to make sure that it all looks consistent. So the trees will be moving with the same wind as whatever else is moving. I don't know. Yes, so I guess it's sort of driving the simulation of each individual other thing, I suppose, is the best way I can explain it.
Brilliant, thank you. And then Sarah, by the way, I hope your question was kind of answered before, a question about learning coding online. Kaylee would like to know, again for you, Eugénie, this is, could we create a sort of projection or screen filter that would mean that on a ride or in the cinema we'd be able to watch a movie in 3D without wearing the 3D glasses?
Yeah, it's complicated. There are, I actually am not, I think, I know some of the technologies, not all of the available technologies. There are glasses-free 3Ds, but they usually involve a very, very narrow viewing angle. You have to stand in the right place, basically, for it to work. So it's pretty impractical. I don't know. I'd have to go out and see what the latest greatest is on that. But it is, of course, something that everybody wants.
I just remember having to try and perch the Jaws 3D glasses over my great big NHS specs when I was 13. It was a very problematic time in the Watford Odeon. This is, let's ask, this is from Sean C. And Sean C, I'm going to actually try and pronounce this, I think, how he would like me to deliver this. 2.5 years ago, Matt promised us on YouTube an update on the three-sided coin problem. Nothing. The second one was in caps lock, obviously.
Thanks. Yeah, so actually I have got a mild update for Sean C. So to recap very briefly, the three-sided coin project is if you've got a coin, it always lands heads or tails. Very rarely on the edge, but overwhelmingly heads or tails. But if you think about a coin as a very flat cylinder, if you were to extend that into a very long cylinder like a pen, you'd still have like heads and tails, but now this is all the edge. If I throw a pen, it always lands edge. Very, very rarely heads or tails. And because it goes from one extreme to the other continuously, somewhere in the middle will be a thickness of a coin that lands equally heads, tails, and edge. And so I started a project to try and find out what that is. And in what appears to be the theme of the show, it's complicated. And we had a lot of progress. I actually had a meeting just this week, just gone, with an engineering friend of mine, Hugh Hunt, who was there with the original part of the project with me, and a bunch of his engineering undergraduate students, because he lectures in engineering, about trying to advance that project. And I can give you a spoiler. A while ago, I sat down and flipped a coin 10,000 times to work out the exact probability of it landing on its edge as a standard coin. And so we're going to be analyzing that data and hopefully generalizing it to finally answer that question. So the answer is soon.
Brilliant.
As experimentalists, can you not just get some sort of plasticine or something and make lots of different aspect ratios of coins and try it out?
We did that. We 3D printed different ratios of coins, and we've got upper and lower bounds on what the ratio will be. I've actually got a lot of data from people who 3D printed coins and flipped them, but things like the elasticity of the material of the coin, the friction of the surface, it's complicated.
Right, we're nearly. I think we're going to do it with the question. I'll just quickly mention again, by the way, as I mentioned at the beginning, if you are able to support us via Patreon, that is fantastic, because we have basically no other work, and we're trying to make a week at the moment, and we're trying to make them as good as possible. So if you're able to support us, if you're not able to support us, but you're able to spread the word about Cosmic Shambles and all the different shows that we're doing about science and existence and art and strange horror films, etc., then if you can spread the word, that is part of it as well. As I said, we just need to get 5% of our audience supporting us via Patreon, and then things will be much easier for the time being, at least. This is from Rob Eng. Now, Helen, I don't know if you remember Rob. He has popped up a couple of times before, when we had Hannah Fry on and when we had Nara Chamberlain on, and he's remaining with the same question because he feels that no one has answered this yet. He's been having a battle with his brother now. This is a sibling rivalry issue that's been going on for quite some time, and the question is, much like rectangles and squares, graphs can be charts, but charts can't be graphs. True or false?
So,
Matt, I'm going to start with. Sorry. I
thought you were going to ask, but yeah, let Matt.
Well, I think you've answered previously, so I'm just going to first go to Matt, and then maybe if Eugénie's gone. So there we go. So that's the question. Graphs can be charts, but charts can't be graphs. True or false?
True.
Right. Eugénie, what do you reckon?
I have no opinion.
That's exactly where I stand on this matter as well. Helen?
It's the wrong question. That's what I think. Because, sorry to the questioner, but the point is, you're making an assumption that the world works in a way where there is a clear answer, and human language doesn't work like that necessarily. It depends on how people use it. It's contextual. So I think this is one of the problems actually with theorists in the world, is that they go, it must be this or this. There must be a category, and you have to, categorization is careful. It's useful sometimes, but you have to be careful. And so I think the problem is that look at how much sibling rivalry you can waste on this when you could be using it for something much more productive, like which way around the toilet roll goes on the toilet roll holder or something. So I think the problem is, if you go looking for a question that doesn't have an answer, you just waste a lot of time, and you need to choose your questions for your experiments. So I think I would advise moving on to another topic.
Well, that was often said to the Hitchens brothers as well. We would advise it, but it didn't stop that sibling rivalry. So I believe that Rob and his brother, this is a sibling rivalry that will continue to the grave and possibly beyond. This is Oliver would like to know, Eugénie, what is the most impressive bit of CGI that you have ever seen? In fact, I'm going to change answer, but I'm also intrigued by what into the first time that you saw CGI and you thought, wow, this has now moved into a different league.
Okay, that one's easy. Jurassic Park. I think it's sort of the combination of Jurassic Park and Terminator 2 coming out in the early 90s. What I saw and just went, completely changed, filmmaking. So that one's easy. But the what's the most impressive CG I've ever seen? There are a few contenders, but I would put the Planet of the Apes movies sort of up there. Probably it's the first ones that come to mind. Maybe Davy Jones as well, from the second Pirates film. Amazing.
Oh, I'm
just
so
feel
disappointed.
Completely alive.
I thought you meant Davy Jones from the Monkees. I thought it was actually going to be that in 1967 it turned out that Dolenz was real, Torque was real, Nesmith was real. The war for, I can never remember if it's the War of or War for the Planet of the Apes, but that film is an utterly, if people haven't, first, if you've not watched the film, watch it. It is a masterpiece of a film. It is a great film, but by any standards, I think. But then watch how they do the effects and how those actors, what they work around. It is quite amazing on so many different levels. Martin Skates, here we go. He has a general science shambles question for you. This concerns how to prevent water pipes freezing in winter. My dad insists on letting the bathroom tap trickle during cold snaps, as he insists that running water does not freeze. This is apparently a common thing, and while I appreciate his point behind this, I do find it a little wasteful and only serves to increase the bills. Some of the major utility networks actually claim that it's a myth to let the taps run, as it may encourage further problems. What is true and what isn't? With that in mind, what other options can be considered to conserve water? So, Helen, that seems like a very pragmatic question where you've probably done some experimentation. You've been to many frozen places. What do you reckon?
I don't think running the tap will stop the pipes freezing. The only thing it might do is dislodge bits of ice where ice is starting to grow and carry them along so they don't accumulate in one place. So it might get rid of nucleation sites a little bit, but it is very wasteful of water. So I don't know. I don't really understand why insulating pipes better isn't. Yeah, I don't know. I have to confess, I don't know much about the practicalities of the sort of water pipe he's talking about. So I think it might make a small difference, but only in specific situations, and it's definitely very wasteful. So I don't have a recommendation, but sorry.
Either of you, Eugénie, Matt, would you like to add anything on the tap conundrum? No, good. There we go. That's where we're going to end. Amelia, I hope your question was answered earlier when Matt talked about Python. If not, do just tweet Matt, because I'm sure he'll reply. That's another coding question, just a bit of advice about learning coding. I apologise to the 3 people that we didn't get to your questions. We always get there. We'll get there in the end. Next week, as we said, we're doing weather and climate. And so start sending your questions now. You can just go to the Cosmic Shambles site, and you'll also find at the Cosmic Shambles site, as I said, our latest episode of Uncanny Hour, which is about why we believe in UFOs as alien visitations and what that says. And that's some very interesting points from David Clark and Sarah Scholes and others as well. The latest episode of Book Shambles, I'd really recommend. Alexi Pappas, who is an Olympian and also an actor and a writer, and she has written just a remarkable book about the kind of book that I would not necessarily pick up if I saw in a shop. Think, oh, this is probably not really aimed at me. And it's a really great book dealing with so many different things. The death of a mother who took her own life when Alexi was only 5, about her battles being an Olympian, about being a female Olympian in things like long distance running, about depression, mental health, creativity. Josie Long and I had a conversation with her. That's up at Book Shambles. And that's it for the time being. And so go and have a look. I think there's about 5 new things that have gone up in the last kind of few days. And also our Patreon supporters. Next week, we will again try and do a few behind the scenes things where you can come and join some of the live conversations that I have before we actually edit them down and turn them into shows. Thank you very much, Eugénie, Helen, Matt, and thank you very much to our producer, Trent Burton. And we will see you next Sunday, if not before.